Thank you to Duncan for the introduction, thank you for the invitation, and thank you to the whole Fifth Sense team for putting together such a fantastic agenda and a fantastic afternoon. It's great to see everybody here, some familiar faces, some new faces, and it's been great to talk to some of you. So I'm going to talk to you for the next sort of 20 minutes or so about Rhino Therapeutics and our mission to develop new disease-modifying drugs for people who are living with olfactory loss, so people who have lost their sense of smell. I'll start off by telling you a little bit about the company, and then I'll move on to where we're focusing on and why, how our therapeutic approach is intended to work, and where we are at the moment. And then I'll make a couple of comments at the end about olfactory testing, which is obviously incredibly important. So Rhino Therapeutics has been established as a legal entity, as it were, for about a year now. And the four co-founders are shown on the screen. Andy, my colleague, is sat over there. Perhaps, Andy, just wave your hand so everyone can see you. And then my other two colleagues and co-founders, Professors Brad Goldstein and Jim Schwobe. Those of you who were at the Fifth Sense meeting 2 years ago in Manchester will have met both these gentlemen. They are at Duke University and Tufts University, respectively in the US, and they are experts in olfactory regenerative biology. And I may get my maths slightly wrong here, but I think between them they've got something in the region of 50 years of experience of the olfactory regeneration process and how the olfactory tissue repairs itself in the normal scheme of events. So Rhino Therapeutics is a virtual company. We don't have labs, we don't have offices, but what we do have is we have a legal presence in the UK and in the US, and we do our work. A virtual company means you do your work by working with other companies, and so we do all of our scientific work by collaborating with companies in the UK, in Europe and elsewhere. Now, the single most important thing probably on this slide is this point here. We are, I think we've been out there trying to raise money to get the company established for about 3 years or so. The idea behind Rhino is about 4 years old, give or take. We've been trying to raise money for 3 years. We spoke to a lot of people, well over 100, probably nearly 200 investment groups of various flavors and types, some good, some not so good. And it took us a long while to get the money raised, and it was very tough. It's tough raising money in biotech anyway. It's even tougher when you're trying to sell to people the idea of starting a company based on developing a drug for a new therapeutic area that nobody else is doing. So not only do you have to convince them of the scientific value of what you're doing, you have to convince them that it's actually worth doing as well. And we were fortunate enough to be introduced to an investment group called Curie Bio, and I'll tell you more about them in a little while. And we secured our funding with Curie Bio in July this year. So the important point is we're actually now starting our work, which is really, really exciting. Obviously, things like COVID have helped raise the profile of smell loss and the importance of it and the impact it has on people, but it was still very challenging to get the money raised. So we have a singular focus, a singular mission, and that is to develop disease-modifying drugs for people who have lost their sense of smell. Our initial focus is on age-related olfactory loss, or presbyosmia, and I'll explain why that is in a moment. We're obviously very interested in all forms of smell loss, and our long-term vision is to try and tackle them all. So the therapeutic focus is our main angle, as it were. But as we've been hearing from other speakers and in conversations within the room, there is a whole range of other challenges that we're facing here. One of them is raising awareness of smell loss, how it impacts people, how it makes them feel, etc. And we're working with Fifth Sense and others on that. We need to generate more data, more information about who is affected, why are they affected, what are the mechanisms that are going on underneath, and so things like patient databases are going to be very important. And then olfactory testing, smell testing, is going to be absolutely critical, and getting that undertaken more regularly and more routinely in all healthcare settings is going to be really, really important. And obviously getting drug regulators to understand this as well is very important from our perspective. So I'll just say a few words about our investors now. As I say, Curie Bio. They are a US-based investment group. They invest in early stage opportunities. It's called the seed stage of investment. They've not been around too long. They were founded last year, but they have been making a big splash in the investment community. And there are two reasons for that. One of them is that they have some very serious financial backing. So they have a fund in excess of $500 million to deploy into new and innovative healthcare and therapeutic companies. So obviously a very, very large amount of money there. But the other thing is they have a very different operating model to most investment groups. And a lot of investors, if they invest in a company, they will come in, they'll put a certain amount of money in, they will perhaps have seats on the board of the company, and they will oversee what's going on. They'll maybe check in with the company, on a quarterly basis, which is great. But Curie Bio are much more involved and much more active in terms of interacting with the companies that they fund. And that's really good. That's a very positive thing, because not only are these guys investors, but they're people who have been there themselves. They're people who have started companies, people who have seen the challenges, people who have seen the mistakes that can be made. And what they want to do is they want to basically try and position their investments so that they are more likely to succeed. I mean, it sounds like common sense, right? But these are one of the first guys to do it. So it's really exciting and really encouraging that we have been funded by them. But most importantly, what it does is it shows that people are recognizing this unmet need that's out there for olfactory loss, and it provides critical validation, and from a really serious group. So this is a start, and it's going to things will go on from here. This will stimulate other investors to get involved, and there will be other companies founded. We have no doubt about that. Okay, so I'll just comment now on discovering drugs for things, but olfactory loss. So I'm going to stand over here, I can't quite see that. Discovering drugs for olfactory loss. Now, the points here kind of relate to discovering drugs for any condition, really, and very simply, the more information you know about a condition, the easier it's going to be to discover drugs to help it, to affect it in a positive way. And olfactory loss, as we've heard from several of the other speakers, is kind of an umbrella term, which refers to having lost the ability to sense odorants and to process them. And it can be caused in a number of different ways. And the causes and the mechanisms differ for all of them. So, for example, head trauma-induced anosmia, where the connection between the olfactory sensory neurons and the olfactory bulb is damaged or sheared. So the impact, if you like, the damage is incurred at this point, is different to post-viral olfactory loss, where it's the olfactory neurons that are damaged. So that means, in principle, there are different mechanisms operating, there are different causes, and so potentially then there will be different solutions required, different drugs would be needed. And what we need to do is we need to understand the mechanism by which the olfactory loss occurs, and then we need to match the drug to that mechanism. And as I've indicated, different approaches may be needed to treat each form. It's also important to say as well that some forms of smell loss may be easier to treat than others. That's just a simple fact, unfortunately. And what we need to do as a company developing therapeutics is we need to find the right drug for the right patient. And this occurs across all therapeutics, but obviously, our interest is in olfaction. So I really don't want to say too much about this, about presbyosmia, because Nick Rowan did such a fantastic job of summarising it. So all I will say is that the term for age-related olfactory loss is presbyosmia. As we've heard, it affects a lot of people, and the prevalence increases with age. But actually, this kind of then speaks to the routine testing aspect, is because there is a lack of routine testing of individuals' olfactory competence, either just as a one-off or on a longitudinal or on a repeated basis. We don't really know how many people actually really are living with olfactory loss as they get older. We have some guidance figures, and the easy answer is that it's a lot. What we also know is that declining olfactory ability is linked to multiple other health problems, including increased frailty. And again, I won't comment any further on that because I think that was explained very comprehensively by Nick. Now, I'll come on to this in a moment, but our initial focus is on presbyosmia, and I'll explain why in the next slide. But one of the points is that the damage which occurs in presbyosmia is characterized by damage to the olfactory epithelium, the tissue which contains the olfactory sensory neurons, which receive the odorant and then process that information and pass it onwards. And actually, the damage in presbyosmia is not dissimilar to post-viral olfactory loss. So although our initial focus is on presbyosmia, what we intend to do in the longer term is to test efficacy of any drugs we develop in post-viral loss as well. And we think our approach may be beneficial there as well. But it's less well understood, which is why we're focusing on presbyosmia. So as a general rule of thumb, in order to give a new drug the best chance of success in a clinical trial, you need to know more about the condition that you're trying to treat, as I've indicated. And that, of course, is what we want to do. And so what we need to be able to understand then is the nature of the damage to the olfactory system in the particular condition and the mechanisms which cause it. And the good news is that we know quite a lot about how presbyosmia is caused. And again, there was a very expansive description of that from Nick earlier. The long and short of it is age-related wear and tear is a big problem as you get older. I mean, it's the only tissue, it's the only neuronal tissue in the human body that's exposed directly to the external environment, and the external environment throws a whole lot of nasty things at our olfactory tissue. Not just things like viruses, but horrible chemicals coming from all places, small particles, pollution, that kind of thing. And all of this damages the olfactory tissue. The good news is, of course, the olfactory tissue can repair itself, and it does so routinely. In the normal situation, the olfactory epithelium repairs itself about every few weeks or so. It regenerates and repairs itself. But as we get older, that repair process becomes less efficient, and eventually it starts to wear out. And this results in a process called neurogenic exhaustion, and this is where the stem cells, which normally repair the olfactory system, they basically they stop doing so, and they run out. And what this then does is it leads to a loss of the olfactory sensory neurons, which are the nerve cells which detect the odorants from the atmosphere. So again, just to reiterate the point then, if we have knowledge of the mechanism of what's happening, which we do here, that gives us the best chance to design drugs to correct the problem that we're seeing in patients. And just to illustrate the difference between, if you like, an older person's olfactory tissue and the olfactory tissue in a younger environment, these two tissue sections here, which come from Jim Schwob and Eric Holbrook, this is embryonic olfactory tissue, And you can see it's very smooth and dark here. And what this dark brown coloration is composed of a series, lots and lots and lots of little tiny dots. And the dots are where a particular protein, which is expressed in olfactory sensory neurons, has been labeled. So what this is telling us is there's a whole lot of olfactory sensory neurons in this area here. Now in an older individual who was 86 years old, according to this section, you can see you've got much more of I suppose, a moth-eaten olfactory tissue. It doesn't take a genius to realise that this doesn't look as nice and as effective as the younger situation. What we don't actually know, just as a by-the-by, we don't actually know what the olfactory status of the individual that provided this tissue actually was. But the long and short of it is their olfactory epithelium is not covered as well with olfactory sensory neurons as in the younger environment. So how are we actually going to achieve this repair process? How are we going to reactivate the regeneration of the olfactory epithelium in a situation where that process has stalled, where that regeneration has stalled? As I indicated right at the beginning, our academic founders, Brad and Jim, are experts in olfactory regeneration. They know all about the signalling processes that are going on. They know loads and loads about the various cell types that are in play. And again, this is quite a complex schematic here, but what I'd just like you to focus on is this diagram at the bottom here, this cartoon. And what this shows is it shows a schematic of the olfactory epithelium and all of the cell types that are contained within it. And right at the top here, you've got the cilia, the projections which come from the olfactory sensory neurons. And these cilia contain olfactory receptors. This is actually a schematic of one. And what they do is they sense the odorants. So as we heard earlier from Rachel, the odorants are chemicals in the atmosphere. We can't see them, but they're there. And what some of them can do is they can bind to receptors, and there's about 400 different sorts of receptors on olfactory neurons. Though interestingly, each olfactory neuron only has one type of receptor. And the odorant will bind to the receptor on the olfactory sensory neuron. It will trigger an impulse, and then that impulse goes through the system up to the bulb and then into the brain, into the central brain. You've got a whole bunch of other cell types in here as well. You have these kind of, I don't know how I'd describe them, these kind of pink cells, which are called sustentacular cells, and they're supporting cells. They basically provide some structure to the tissue. And then the really important cell types are down the bottom here, the green ones and the blue ones. Now the green ones are called globose-basal cells, GBCs, and these are the kind of the workhorse cells. These are the cells, the stem cells, that actually undertake the regeneration process on a day-to-day and a week-to-week basis. They're the ones that are regenerating the olfactory sensory neurons and the sustentacular cells in the normal scheme of events. The blue cells are called horizontal basal cells, and these are cells that normally actually they just sit there and they don't actually really do a lot. They just sit there quietly minding their own business. But when these cells are called into action when there's serious damage to this tissue, when the natural process of repair and regeneration is really being impacted by the external environment. And what we know is that these horizontal basal cells, they can give rise to all of the cell types in the olfactory epithelium. So they can give rise to the globose basal cells, the olfactory sensory neurons, and the sustentacular cells, which is obviously really exciting. Now, when you have tissue damage to the olfactory epithelium, either by viruses or other external insults, and also by aging, what's really important here, and again, it's sort of summarized, not 100% accurately, but good enough for now, I think, in this schematic here. So if we use the term injury to define viral damage or perhaps aging, you get a loss of all of the functioning cells which receive the odorant information and which pass it onwards. And you're basically left with just the stem cell population. Now actually in aging, you actually lose these green cells as well. You don't actually have any of the globose basal cells as well. So what you've got is you've just got these blue cells. All you have left is the horizontal basal cells, and they're just sitting there minding their own business because they've not been activated. But if they could be activated, what we would expect them to do is to start the process of regeneration and to start to regrow all of the cell types in the olfactory epithelium. And what Jim and others have shown, what Professor Schroeb and others have shown, is that those horizontal basal cells can indeed be reactivated in various model systems in their labs, and when they're reactivated, that regenerates the olfactory sensory neurons and all of the supporting architectures. This is really exciting. So what we want to do, and what we are doing, is to take this academic work from the founders' labs and to translate that into drugs which we can then use potentially in patients ultimately, drugs which we can apply directly to the damaged olfactory tissue that will reactivate the horizontal basal cells and then restart that repair process, to kickstart that repair process. And that is, would be termed as a disease-modifying drug. So it's obviously really exciting. So probably the question everyone's got in their mind is, well, where are we? You know, told us about this is very interesting, but you know, where are you and how long is it going to take? Now, we've obviously only just started. The funding from Curie, as I say, came in at the end of July, but we're a few months down the track now, and it's enabled us to get our drug discovery program running. And what we're doing at the moment is looking to identify prototype drugs, sort of early stage drugs, which can activate the horizontal basal cells in cell models. So it's a very sort of early stage of the process, but within the next few months, we'll have moved on significantly from here, I think. An important point to note is on timeframes. So drug discovery is divided into sort of three broad phases, which I've just illustrated on this schematic here. You've got the research stage, where you're looking to identify a prototype drug from a whole range of options. You've got preclinical assessment, which essentially is priming your prototype drug ready to go into the clinic. And this involves a lot of work, particularly on safety, but also bolstering efficacy and other profiling as well. And then the prototype drug can enter clinical trials. And this whole process takes quite a few years, as I'm sure a lot of you know. But from our perspective, from the perspective of where we are at the moment, we are focusing on these two stages of the program. And we think it's going to take us around 3 years to go from the standing start from July, sort of mid this year, through to a compound which is ready to be progressed into human clinical trials, ready to get the regulatory approval to go into clinical trials. So it's going to take about 3 years, and it's going to take around about £12 million, we think, to do that. So it's not cheap. But this is pretty standard for the type of drug discovery we are doing. And obviously we're backed by a very serious investor here, so we're well positioned to do that. We are going to need additional investment and funding before we start our clinical work. But again, if we've got a fantastic data set which contains all of the right information on safety and efficacy, then we think we're going to be really well positioned to do that. So the exciting, obviously, point of this is we've got the work started. It's taken us sort of 3 odd years to get to this point, and we thought it was hard to raise the money, but it's even harder to do drug discovery. So we're really excited to move this forward. So just changing tack very slightly. We've heard a lot about olfactory testing, and I think the key points here are that we need more of it. It needs to be more routine and more regular. And along with Duncan and Steve, Andy and I are heading off to Philadelphia tomorrow to the chemosensory, universal chemosensory testing meeting that Steve outlined. So this is all a really important part of building the message and helping to drive the necessary change in the testing paradigm. We all know about how olfactory dysfunction can affect our health and well-being of all types. We know about the health problems that can be linked to olfactory decline. And so I'm sure I'm not alone in this room in finding it rather counterintuitive that routine olfactory testing is not undertaken outside of specialist clinics, and that needs to change. And we've heard that message loud and clear today, and I'm sure we're going to be hearing it in Philadelphia as well. We know that the testing is non-invasive, it's relatively easy to do, and it gives a reliable quantitative assessment of any individual's olfactory ability, and it could provide a really important indicator of other problems and enable faster intervention down the track if that testing was undertaken. And so we're working with FistSense and others to drive that change in practice. And the way I always think about this is, we've got multiple senses, and we hear a lot about sight and hearing, and olfaction and olfactory testing needs to be given parity with these other senses. And we are starting to get that get that voice heard now, which is really important. But I kind of have I suppose perhaps a slightly naive vision, perhaps slightly aspirational. But every time I walk down the high street, I see this kind of thing. I see an optician's, and I see a hearing assessment in particular place. This is actually one of my local opticians. Other brands are available, by the way. So we see this, and every time I walk past it, I'm normally walking past it with my partner, and I'll say to her, "Gosh, this drives me nuts. It's great. It's fantastic. We need to do this, but this is what we need outside them as well." And I hope that in the coming years, this is a place that we're going to get to. And not only will we have wider testing in primary healthcare and in specialist clinics, but it will be something that, in the same way that you could walk into Specsavers tomorrow and get an eye test, you'll be able to walk in and get a smell test as well. So that's pretty much it from me. Three kind of wrap-up points, I suppose. We're a biotech company, so our primary focus is on the therapeutics. But olfactory dysfunction and anosmia or hyposmia, it's a brand new therapeutic area. No one really is developing drugs for this at the moment. There's only one other company that we are aware of that is actually working in this space. And to our knowledge, Rhino is the only company that is looking at disease-modifying therapeutics for olfactory loss. So this is going to present us with obviously a lot of exciting work to do, but it's going to present us with some challenges as well. We're doing this for the first time. We've got to engage with regulators. We've got to engage with, particularly in the US, with insurance companies and payers, so that people know that this is a problem that's very serious. If we can have drugs for it, then it will benefit people in the longer term. It will have a positive healthcare impact overall. And again, we've got to work together as a community to do that. And part of it then is raising awareness and getting our voice heard. And as Duncan will recall, when we had a conversation with Nick Rowan several months back, Nick said, we need to be the squeaky wheel. So people need to hear us. They need to be listening to to the messages that are coming from groups like this. And then, of course, again, just to bang that drum, again, we need regular smell tests. People need access to these, and we need to be undertaking them because it's such an important marker of our overall health. It's going to have nothing but a positive impact to actually do that on a regular basis.